Hello. This next problem that we're going to do, exercise 16, problem set 10, is based on Pascal's principle. Pascal's principle. And there is, I'll read the problem to you. It says, Eliza, an auto mechanic, is raising a 12,000 kilogram car on her hydraulic lift so that she can work underneath it. If the area of the piston is 12 centimeters squared, while the output piston is 700, okay, what force must be exerted on the input piston? Okay, so you have two pistons. These are both pistons. There's a pair of pistons, okay? This one is 12 centimeters squared, and that's going to be the input piston. In other words, that's what I'm touching. That's what I am putting my force into. So that's the input force. Remember, the output force is the job. What do you want done? Well, I want to raise a 12,000 Newton car. I want to put a 12,000 Newton car on this piston here, and I want to push down this to raise this. Now, we're not talking about height or length or DI or DO. That's not what we're talking about. We're not talking about how far we have to push this down. That's not what we're talking about. What we're simply talking about, that this can be very long, but it's what force do I have to apply here? What force do I have to apply here so that the car will be lifted by that piston? So this is the input, this is the input. This is the output. So the input area and the input force are here. The output area and the output force are here. That's the actual job you want done. 700 square centimeters is the output piston, because that's getting it done. So what do I want? Well, I want a 1,200 kilogram car raised up. Okay, that's the job. So that's going to be the output force. Now, I know that this is essentially Pascal's principle. The pressure that I apply here is going to be the same pressure applied there. It's going to be the same pressure. Okay? They're equal. You see how that pressure, the input pressure, equals the output pressure. So this is going to be the pressure input. This is going to be the pressure output. They're equal. They're equal. Okay, now, therefore, you have the input, I got this written backwards, but anyway, this is output so this is going to be 12,000 is going to be the output force. 700 square centimeters is the output area. The input force is what you're touching, what you're applying. And 12 centimeters squared is the area of the input area, okay? Input side, output side. Okay. So 12,000 times 12 divided by 700, and the answer is, I did this before we started, is 206 newtons. So it's going to be 206 newtons. So you take a 12,000 Newton car, which is about right. That's about 2.5 tons. 12,000 Newton car being lifted by only 206 newtons. I weigh 1,000 newtons. I weigh 1,000 newtons. So, 1/5 of my weight can lift this car. Now remember, we're not talking about how high you lift, how far down you have to push one piston, how far up you're going to, raise the other piston. We're simply talking about applied force. Applied force. This is the input side, this is the output side, input pressure, output pressure, input force, input area, output force, output area, input pressure equals output pressure. Solving, I get 206 newtons. Monday's quiz, very important, okay? Now, that is exercise 16, problem set 10. Now, I may ask some questions that are fundamental to doing this problem, but I didn't necessarily say, okay? You know, I said, they give you the mass. They did the problem, and they gave you the answer in the book. They didn't tell you that the output force was 12,000 newtons. You should recognize that relative to the weight equals mg, okay? Enough said. Talk to you later. Be right back, and we'll do another problem, and then we'll quit for the day. Be right back.